So let's take a look at the graph of this hyperbola. First of all, you can say that these guys are divided by 1. And so on the y-axis, go up plus or minus 1. And since the y is first, it's then going to be opening this direction. So here are the two branches of the hyperbola. And then some people believe that that looks like just two parabolas, one facing up and one facing down. And what we're going to prove in this one is that these are not parabolas. So we'll pick this one up here and prove that this one is not a parabola. Well, the general equation for a parabola is y equals ax squared plus bx plus c. At least for a parabola that's opening either up or down. And if I'm going to have this one, the a is going to be positive to have it open up. The next thing to do is find 3 points on this thing. So we've got this point, which is 0 for x and 1 for y. And find 2 more points. And if you can find any 3 points in space, there's going to be exactly one parabola that goes through there. So what we need is some other numbers. For example, if x were how about a 1? Oops, on this side it's -1. And on this side it's +1. What are we going to get? So if x is a 1, this is going to be a 1 squared is 1, but because of this it's negative. Move it to the other side. So in other words, we've got y squared minus 1 squared equals 1. The 1 gets squared. It's still negative. There's still a subtraction sign in front. Move it to this side. Y squared is equal to 2. So that means the y is equal to the square root of 2. And if we were talking about this one down here, we would also use the negative square root of 2. So now we have our 3 points. So for each of these, take x and y and substitute it into the equation. So I'll start over here that y is a a square root of 2, and then -1 for x. So it gets squared and becomes just a 1. A -1 times this, and then plus c. Next, substitute a 0 for x and a 1 for y. So that's going to be 0. That's going to be 0. We found out that the c is equal to 1. And then for this one, we would have that, well, it would look like this equation except be positive. Everything would be positive. So there's the square root of 2, and then a plus b plus c. And then we can use the fact that c is equal to 1, substitute that right here and right here. And then if you add the two equations together, the b's are going to cancel. So we have the square root of 2 and a minus b plus 1. We have the square root of 2, the a plus b plus 1. And so add these together, and there's going to be 2 square roots of 2. There's going to be 2 a's, and there's going to be a 2. The b's are gone. And now divide everything by 2, and we've got that a plus 1 equals the square root of 2. So a is equal to the square root of 2 minus 1. So the square root of 2 minus 1, 0.414. And now we just need to find the b. So go to any equation that has a b in it, let's say this one. And we've got the a and we've got the c. So the square root of 2 equals a plus b plus c. And now solve for b. So that's going to be the square root of 2 subtract a 0.414 and subtract a 1. And it is pretty much 0. Let me do the whole thing in the calculator. So A is, oh actually I can see it here. So A is the square root of 2 minus 1. So if you put that in here, you'd have a square root of 2 on this side, and that side they cancel. You'd have a negative 1 and a positive 1, they would cancel. The B is equal to 0. Alright, so now we've got our function that the only parabola that will go through these 3 points is this parabola right here. Y is equal to A, which is 0.414, or more accurately I should use the square root of 2 minus 1, and that's the coefficient of x squared. The B is a 0 and the C is a 1. There is the parabola. And then how do you prove that the parabola and this ellipse are not the same? Well, just pick one more point that's on the ellipse. So let's say we go out farther to where x is equal to 2. So then we would have y squared minus a 2 squared then equals 1. So this is going to be 4. Add it to the other side, and y squared is equal to, 4 plus 1 is 5. So y is equal to the square root of 5. So 2 and the square root of 5. And if the parabola and the ellipse are the same, those numbers, 2 and square root of 5, should work for x and y over here. So if we have y equal to the square root of 5, does that equal, and like I said, I'm going to be completely accurate in here and use this where the a is actually equal to. Square root of 2 minus 1, and then x is squared plus 1. It's really a question. Do those numbers work for the parabola? And it's going to be the square root of 2 minus 1 gets multiplied with a 4, and then add a 1. So a 2.657, does that equal the square root of 5? No. 2.236, it's not really even close. So there's the proof. So the only parabola that will go through there does not then go through that point, which the hyperbola does.